Okay, so far in this module, we've looked at how carbon plays out in our environment, the release of it into the environment, the greenhouse effect, how that works with climate change and how it's impacting us. And then we've looked at how we might consider and think about the buildings that we build and the energy that goes into it and the carbon emissions that are released through building it, living in it, occupying it, and demolishing it and recycling it at the end. So now I'd like to progress on and look at a couple of the tools. We'll just touch on these so that you understand what is available out there to be able to use and how you might bring these into play when looking at a project. And we're going to demyth maybe 10 or so of the myths around net zero, zero carbon, and the rest. Okay, so whole life cycle carbon or life cycle assessment. So sometimes you'll see the letters LCA. All of the materials that are going to be used on a building site, in theory, at some point, will one day come with an EPD. So an environmental product declaration, and that will be declaring its carbon footprint, the embodied carbon for that product, right from the beginning of its manufacturing process through to arriving on site. And at that point, the calculation stops. So the embodied carbon of a product early on. This might be called cradle to gate. Cradle to gate. The idea being there, cradle being the life, the new beginning of the product, through to a gateway, a point where the product passes on. And in this case, it passes on to the construction phase for building, and then the occupancy phase, and then recycling at the end. So the EPD looks at the cradle to gate calculation. Sometimes you'll hear the phrase cradle to grave, which is the whole life cycle. Okay, so one of the tools that we use is PHPP. And PHPP is a bolt-on to a package called the Passive House Planning Package. Focusing on the PHPP, we're looking at the data that it outputs, and there's lots of graphs and tables here. And we'll just sort of summarize them so you understand what you might be looking at. So we have upfront carbon, and the orange section is about the product and its manufacturing phase, and then the transportation out to the site. Okay. The use of the building. So this is the lifetime of it, the occupancy, maintenance, repairs, replacements, refurbishments. All these things come into play. And then the end of life, transporting it away, waste processing, and disposal. We've already talked about these two tables here and looked at how the carbon can be stacked up and how we can then look at it over the years and see the amount of carbon that is used by a building so that we can get that holistic whole life assessment. One of the things that these graphs show, quite interestingly, down here in small, is we have the RIBA and the LETI assessment. Now, both of these calculations, one says 342 and one says 330. Two different numbers, both providing us with a whole life cycle carbon assessment. But why are they different? So we have two different organizations, and their method of determining what the whole life carbon is different. So they end up with two different equations. The reason I'm showing you this is because when information is presented to us, we have to be prepared to question what that data means. And in this case, the LETI figure suggests that this same building here in this example has a smaller carbon footprint than the RIBA standard. Now, the reason behind that is because one of them takes into consideration renewable energy, and the other one says, no. Renewable energy is to do with the grid. It's to do with the big energy companies. If you put renewable energy on the roof of your house, all you are doing is reducing the amount of renewable energy out in a field or out at sea or wherever the big companies are collecting renewable energy. So one of these assessments is saying, let's not take that into consideration. And in this case, it's the RIBA one that doesn't take it into consideration because they think that, sorry, got that the wrong way around. LETI don't take it into consideration. So their carbon footprint in this situation is lower because solar panels have not been included, whereas RIBA believe that the solar panels should be included in the calculation to assess this building's carbon footprint. The details of which organisation does what isn't what's important right now. What's important is that you question what it means and where the information has come from when somebody tells you a carbon footprint of a certain product or a certain house is X, and you might compare it with something else, but if that something else has been calculated using a cradle to grave or a cradle to gate, or including renewable energies or not including renewable energies, considering the occupancy energy and the recycling, how many years have they considered the building to live for? To get a true comparison, we have to be able to look at comparable data, and so questioning things is important. Passive house planning package. And this is a building that was built in 1991 by Wolfgang Feist, and I know in later modules you'll hear a lot about passive house because it is the core of this training program that you'll be doing. It was first built in 1991, and this is its data sheet. And its data sheet, from a very complex spreadsheet where data about the size of the windows, the orientation of the building, the thickness of the walls, the types of materials is all plugged in. And we're talking around about, I think, 15 to 20 pages of data within a spreadsheet. Come up with one important number. 14 kilowatt hours per meter squared per annum. That is the energy demand of that building for occupancy. So once the building's been built, whether it's out of timber or concrete, and the embodied carbon aside, the building needs 14 kilowatts of energy per square meter going forward. So that is its assessment. We add that to the embodied carbon, and we start to make progress in understanding that whole life cycle. So the passive house planning package is a tool that will enable buildings designers to forecast incredibly accurately the performance of a building. This particular software and this tool is renowned for having an extremely tight, small performance gap. What that means is when this house was designed, pen and paper, and all the numbers were plugged in of how it was going to be made, then it was made and measured. They found that the performance gap between the design calculations and how it really performed were extremely close. There are no other packages of software that we're aware of that can compete with the passive house planning package for measuring the occupancy energy of a building. Okay, so let's have a think about some of the myths and some of the things that you will hear. So we know that there's no real standards out there. There's no real controls. So one of the phrases you're going to hear us talk about a lot is greenwashing. And there is a lot of greenwashing in the industry where people band about net zero buildings and phrases as such when it's not really appropriate to. So if somebody says to you, we build net zero buildings, it's up to you to be able to challenge whether that's true or not. And understanding what they mean by that is how you get your answer. So yes, it is possible for people to build net zero buildings, but just because somebody says it to you, does it mean that their buildings genuinely are? Or are they only looking at the data with blinkers on that suits them so that they can make that claim? Solar panels, are they zero carbon? We talked about this before. So solar panels are an example where the energy that goes into making the glass and silicon is massive. For the amount of energy that we then create from those solar panels, it takes somewhere between 6 and 12 years to repay the carbon energy that was used to actually make that. So if you imagine that you kept those solar panels on a roof for only 20 years, but it took 10 years to offset the energy used to build them, then you've only had really 50% benefit. And that's why it's important probably to use the product for much longer. The next generation of solar panels looks to be bringing the embodied carbon down and still maintaining high levels of performance, which is excellent because that will mean that we'll be closer to zero carbon. We'll be creating more renewable energy and expelling less embodied energy when actually making it. But look at the different manufacturers, look at the EPDs. EPDs are, especially in the solar panel industry, quite difficult to come by because this is the kind of information that actually the manufacturers do not want you to have your hands on because it actually makes the solar panels look dirty because they come with this big footprint. So it's not in the manufacturer's interest to actually release this information. So when going on this journey of designing and building buildings to a sustainable standard, we will find, and you will find, that getting hold of the right data can sometimes be tricky. My building achieved net zero carbon as part of its assessment against the London plan. Not entirely true. So LETI is one of the assessments that we've talked about, derived in the London region. It's now opening itself up to be a wider authority, and their future standard is taking into consideration embodied carbon, but their early standard that they set in association with the net zero definition wasn't the same as what it is going forward. The LCA Lifecycle analysis calculation used to predict buildings' lifetime carbon emissions and influence design decisions are accurate. Not entirely true, because EPDs, which I just mentioned a few minutes ago with solar panels, aren't all that readily available. Most products probably don't have them, so we tend to, when designing a building, tend to find a very similar product that may have already had one done by a manufacturer, while another manufacturer probably hasn't. And so we're trying to gather data together on products that might not be readily available. So it is still difficult to calculate out the exact embodied carbon of the building. Existing buildings make it too difficult to get to net zero. Okay, so now we're talking about deep retrofits. And that's not entirely true. Old buildings can be made to be zero carbon if we are talking about the occupancy energy, okay? Because the building already exists now, but through renovation, we would do some work, so there would be an embodied carbon footprint there. Think about it. The age of the building, the style of the building, its location are just some of the factors that need to be considered when thinking about what kind of systems are going to be used. And unfortunately, there is no silver bullet for retrofitting old buildings. Every building is going to need a bespoke system pulling together to meet its individual unique requirements. I'm on a renewable energy tariff, so I like zero carbon. It is possible because some of the energy companies out there buy in carbon credits from renewable sources and sell them onto yourself. However, that doesn't mean that the energy provider has any renewable energy sources themselves, and it doesn't necessarily mean that they are going to invest the money you spend with them on doing so. I think it's Ofgem produce one watt allocation for every 1,000 watts of energy in the market. So we're talking about 0.01% of the market space can be classed as renewable energy at the moment. There are some companies out there that are dedicated to only buying their energy from renewable suppliers direct, or have their own renewable sources and can sell on. So the important thing here to do is, when choosing your tariff, do your research around your supplier to determine whether they are just buying it as a credit or whether they are getting it direct from an energy source, and where do the profits of the company go? Do they go to expand the renewable network, or are they just being shelled back to shells? Burning biomass is carbon and climate change friendly, neutral? No. So burning biomass is taking a carbon stalk, like a tree, and burning it and releasing the carbon that was locked up in there. And that releases straight away. So by using biomass, what we're effectively doing is we're having a carbon burp and putting a whole load of carbon back out there. That's not to say that in 100 years' time, when trees have been grown to replace them and we're into the flow of grow a tree, burn a tree, grow a tree, burn a tree, it becomes a neutral process. But right now, burning biomass is not climate friendly. And with the state of the planet as it is, we need more drastic measures than to be tackling it with a slow approach such as using biomass. Carrying on burning natural gas because your gas supplier is going to decarbonize with hydrogen. There's two types of hydrogen. You've got green hydrogen and blue hydrogen. Green hydrogen is hydrogen created with energy that comes from a renewable source. However, blue hydrogen might have used fossil fuels to create the energy to create the source. The problem we have with this idea of decarbonising the gas network is that the pilot schemes only intend to be rolled out in the years 2030 and beyond, with mass rollout for 2040. This is a climate emergency, and we do need to act far faster. We don't actually have the time to wait around for these technologies to develop. District heating, is it low carbon? It depends on where the source of heat comes from, really. So in Leeds, they use the waste incinerator. So all the black bin waste around the city is taken to a facility, a very modern, super techy place, and the waste is burned and the heat energy is collected, sent to the grid as electricity where possible, and pumped out as heating energy to the district where possible. The problems with that is the emissions that come from burning the waste. Although the facility is supposedly state-of-the-art and only releases steam into the environment, it's highly unlikely that it's as clean as it might be made out to be in the media, and there is still a byproduct of carbon dioxide that is created. So the important thing with a centralised district heating system is to understand where heat energy is actually coming from. If it was coming from a renewable source, then yes. Can any design team essentially build a zero carbon building? Yes is the answer. The information is out there. There are professionals. The network is growing fast. It is about the team collectively coming together. That's everybody in the process. Because building a building has thousands and thousands of decisions to be made. And it's the small margins that make the difference. And by having the whole team collectively focused on making decisions that align with your climate change values, you can progress towards designing a zero carbon building. It may take time, but the information is there and it is out there. And we encourage and applaud anybody that takes on that challenge.
Brilliant. Yeah, thanks, Dave. So that's our 10 sustainable myths. I just wanted to touch on this notion of the performance gap. We haven't actually spoke about EPCs, but you have presented the PHPP. I'm sure we'll go into this in a bit more detail within the course, but maybe if you could just elaborate on that.
Okay, so EPCs, Energy Performance Certificates. Unfortunately, it is a tool that was rolled out probably around about 15 years ago, not fit for purpose and not designed really with this in mind. EPCs are so poorly thought through that the performance of a building is not truly reflected in it as a certificate. It's not a good tool to be using to assess whether or not a building is climate friendly.
Excellent stuff. And you touched on the performance gap. Do you want to just explain that a bit further as well?
Sure. So the performance gap is this idea of bringing theory and practical together. So if in theory our building is going to only use 10 kilowatts of energy per square metre per annum, that's how it's designed. We've seen it in computer modelling. We use the PHPP. When we build it, will that be the reality? And the way to assess that is through monitoring the building through its use to see how close it is. There are a lot of factors to consider with these sorts of things. So the building might be designed to occupy 5 people. However, there might be 10 people living there. So taking into consideration that the building, the way the building is used needs to also reflect the design if you're going to compare whether or not its performance is in line with its design. But the beautiful thing about Passive House Planning Package is it goes into so much detail, it gives an extremely accurate forecast on the building. And that has been proven over the last 30 years, time after time after time after time.
Excellent. So really what we're saying is that the performance gap is on the large part eliminated with the PHPP modelling, whereas with the EPCs there could still be quite a performance gap in terms of what it might be suggesting.
Oh yeah, so an EPC might say that a building is rated B, but because it's got this much insulation in the loft and it's got an air source heat pump attached to the building. However, if the double glazed windows are really badly installed and they're drafty around it, there's huge amounts of heat that will be escaping around those window frames, and the performance of the building, which should be up here, would be down here because the quality of the workmanship is poor. PHPP and the assessment process to see if a house has been built in line with its design requires a lot of evidence, such as inspections to how the windows are installed and if they were installed as per design. If they're not installed as per design, then obviously the quality of the work is known to be inadequate and can either be rectified or it be acknowledged that the building won't perform as designed.